Okay, guys, I'm Sean Saruya, and I created a calculator on Java that finds the limit of a function.
What is a limit?
And so a limit is a point where two sides of a graph approach. And so a limit is written like this. As x approaches actually C is L. And so C right here would be the point that the graph is approaching at x, and then the y value that it would be approaching at is L right here. And so let's say f of x equals x minus 1. That means that the limit of f of x as x approaches 0 is, and then you would get this 0 and plug it in to the x right here, and that would be -1. So the limit of this function, x minus 1, is -1.
So basically, what you're saying is, supposing you have a graph like this, and for x minus 1, you might have something like this, right?
Yep.
Okay, so you're saying as x, this is f of x equals x minus 1. So as x is approaching 0, okay, from either side,
Yeah.
right? Like
a -1.
right. So as x, these are all x's and y's. These are all x's and y's.
They're all points.
They're all points. Yeah, they all have an x and y. As it's approaching 0 from both sides, you're saying that the y coordinate is -1.
Yep.
Okay. Thank you.
But now,
And why would limits be useful in math?
I'm not actually sure. I just started learning them. So,
Okay.
So they just
Well,
taught me how to find
at
them.
the very least, you'll understand what the behavior of a function is as it approaches certain values.
Yeah.
And one of the reasons why you want to create a function is because you want to obtain values at certain points along the graph of the function. So you want to analyze the behavior of the function at certain points. There's some limits, for example, that
don't exist.
and you want to try discontinuity points or whatever.
Yeah.
You want to try to analyze a function for those situations, right?
Yeah.
Okay.
How do I?
You can just close the notepad.
Oh, I'm gonna need. Actually.
You can open up a new instance.
Okay.
Okay.
And so, also, some limits don't exist for like a function like x squared minus 1 over x plus 1. There's gonna be no, that one's here. Okay, the limit there won't exist.
Right.
And so if we try finding the limit of f of x as x approaches -1, then that would equal 0 down here. Well, that would equal -1, and -1 plus 1 is 0, and you can have a 0 in the denominator. So that point won't exist. And sometimes they, even though the point doesn't exist on the graph, the limit still approaches at like a certain point. But here, there's an asymptote, and so it won't exist.
Right.
Because
An asymptote being a line that
an asymptote is looks like that, where as x is increasing, y is increasing, but it never reaches like 0.
Right.
It gets closer and closer.
Infinitesimally close to it,
Yeah.
but it never intersects.
Yeah. Okay. So those are some basic things.
All right. Let me see your code. Let me see your
Okay.
Java code.
So I'm gonna run it first. Let's run it. That's a problem.
You gotta compile it.
I'm gonna close it.
Close the second window.
Yeah. I'm gonna just restart BlueJ. Is this BlueJ?
Yeah.
doesn't have a logo. Can't tell.
No, compile it first.
Oh.
Okay, well.
This is not pretty. Okay, so there's an introduction just saying like where you can't right now. This code doesn't allow like trigonometric functions, logs, roots, absolute values because it's not coded for that yet. It also is telling you how to like the program works. So just to start, press enter to continue, and then the back. Yeah. Okay. So it asks for the first coefficient. And
Okay, so well, let's think about the function we want to put in there.
What do you want to put in?
X squared.
We should do x squared plus 1 over x plus 1.
Just to see.
Let's do one that has a limit. So
Right, that's what I'm saying.
X minus 1.
Let's do the limit as x approaches 3
Uh-huh.
of x squared minus 9. That should give you 0.
Okay. So in the coefficient, you would if you have up to 5 terms, if you only want to use like 2 terms, like x squared minus 9, then you would just type in 0 for like the first 3,
Okay.
telling it you don't want those terms. And then now it would ask you for the coefficient, so x squared is technically 1x squared.
Right.
So 1. It asks for the power, which is 2. And it puts it over here, 1x squared. And then minus 9, you said?
Minus 9.
So you have to type in the negative and a 0 for the power to x. So that says negative 9 to x to the 0 power, and anything to the 0 power is 1. So it's technically negative 9 times 1. And now it's asking if you want a denominator. If you type in 1, it puts a 1 as a denominator, meaning there's nothing. And if it's a 0, it asks you for another 5 terms, like for the top. So we're gonna type in 1 because we do not want a denominator. Now it's asking for the limit, and you said
3.
3, and obviously it says like 1.00 blah, blah, but technically
10 to the minus
negative 12. But that's
yeah.
like 0.
For all intents and purposes, yeah, you're
That is
basically
0.
saying that the limit is 0.00001.
Yeah.
Right.
So it's 0. That's how it
Yeah,
calculates it.
Which you could be getting something other than 0 because of round-off error.
Yeah.
Okay. Round-off error, which sometimes the computer doesn't know exactly how to compare two things that are exactly equal to each other, especially when you're doing a calculation with a double. For example, when you're comparing 0 with x squared minus 2 and x is 2.0, or x squared minus 4 and x is 2.0, sometimes it won't give you 4, it'll give you 3.9999 or 4.201. Okay. We'll talk about round-off error a little later.
Okay, and then that's it.
Okay. Let's see your code.
Okay. So just to start off, this code is very big and messy. When I learned how to start creating my own functions and using classes, I can shorten this code a lot. But right now,
why would learning classes shorten your code?
So I could separate different
Methods and all that?
Yeah. And then creating my own functions, I can, instead of copy and pasting each section for each term, I could use one function that's small for each term.
Right.
So it starts off with importing some classes I need. Scanner for for importing, and JOption pane for also importing. You could also use JOption pane for outputting, but I use it just for the importing of numbers. And then so it starts off with creating the class and the main method. Then it says here scanner. This is the function you use to create the code that you're going to use later for getting inputs. Here's just the introduction that you saw in the beginning explaining how this works. String press key. This is used to get input from the not the GUI,
The console.
yeah. That's how you get input from the console. But here, instead of just getting input from the console, I just used it as a wait key, so that it waits for the user to hit enter, so the program continues. So it stops the code right there until they're ready. And then here, it's the first one is it starts grabbing information for the first term. So it declares all the stuff I need for finding the terms. So it creates the string for getting the input of the coefficient for term 1 coefficient. You'll see how those are used later. So first thing they do is it outputs an input dialog of what they want the first coefficient for the first term to be, and then after that it converts that string to an input, and then here it enters an if statement. So if they type in 0, meaning they don't want the coefficient, it'll skip this part and just set the power to 0, and it'll set the term to, like the string for what the term is, to nothing, so it won't like output anything. When on the module, and if it does equal number that's not 0, then it asks for the power and does the same thing, asks for the power and puts it and saves it as a string, then converts it to an integer, and then it outputs the term with the coefficient of x and the power, and then it prints it. And it does that same thing for all 5 terms, term 2, 3, 4, and 5. Here it asks for the denominator now. So it asks them if they're gonna want a denominator or not. It gets the input, and then it checks to see if the input, if it is 0, then it goes through this next code, which is the same exact thing as 1 through 5. It's just getting terms 6, 7, 8, 9, and 10, which is for the denominator. And if it is 1, then it goes down here. Well, if it's something else, meaning 1, then it skips that part of getting for the denominator. And so here, this part and this part basically are the same. I made 2 copies of them because I was having problems with grabbing information out of the if statement and using it like outside of the if statement, and so I had it. I don't know why, but I had to. So I had to put this code twice into my writing to get the program to work. And so what it does is, it inputs at the end of all of this. It outputs the function the user typed in, and then it asks for the limit that it's approaching, and it gets the limit. Does the same thing as always. Gets it as a string, converts it to an integer, and then it outputs it. So just so you know, like what you type in, and then it does the calculations here. What it does is it's inputting the limit into where the x's would be in a function. And so instead of just using like the actual number, I did something like limit c minus 0.0001, which is like a small number very close to the number they typed in. And I use that because the number they typed in might not actually exist in the function. And so it might be one of those functions where it goes like this, and then there's a hole, and it goes like this, and it's just a function where it goes like this.
Continuous function?
Yeah, and so the point might actually exist, and this will be able to calculate it. And so what it does is actually like subtracts. It makes it a number close to it, so that it's like right here. So it's like the same number basically, and it does that in the other direction as well. It minuses it, and it adds it as well, 0.00001, and then after it checks to see if it's like in a certain range. So if this answer for this whole calculation is like equal to 12, I'm making up numbers here, and this one was equal to like 6. These are not really in close in range, so I would say the limit does not exist. But if it was something like 12.0001 and this one was 11.9999, these are like
for all intents
0.1
and
off. So
For all
they-
intents and purposes, that's
Yes.
12.
So it's like 0.1 off. So I would average them, get the average of this number and this number, and it would average out to something closer to 12. And then this number I would output as the limit, as the answer to the limit.
What if you one other thing you could do is if you want to limit yourself to certain limits, no pun intended. You want to limit this program a certain way, but get an answer that's a little easier to read. You may want to force your answer to be an int, typecasting it, where you put int in parentheses in front of your answer. But the problem is, it won't work if the limit is a double.
That's what I was thinking. Was like I could do an integer, but some of them might not be integers. The answer,
Right.
so I left it as a double, and
Okay.
then it outputs the code. It outputs it, as you can see. It gets the average here. Outputs the limit of f of x as x approaching whatever is the answer, and then if it's not in range, then it'll say that it's D&E, and then that's it. And then the same thing goes down here. It's just a copy of what's up here.
Where does it? It just says DNE, or it says the limit does not exist.
It says D&E, which stands for does not exist.
Okay, very, very thorough analysis, Sean, of your code. Very impressive. I'm very impressed. Your first screencast in Java, just like your screencasts in Dark Basic, were very, very good. Does anyone have any questions or comments? Questions or comments?
Would you see it on the limit side of the textbook?
You want to try?
As
Let's
long
try
as
one
as
more
long as it doesn't have like square root or something, it should work.
Well, what if you do the exponent to be 0.5?
Yeah, like you can do it. You can do it individually. Like you can do like 3x to the half, but this half would only apply to the x.
Right.
I couldn't make it so that it applies to like the whole function
square root
of
of
like
3x.
3x plus 2.
Right. Okay. So, guys, this is a challenge number 2 of this program. Victor is going to read out a limit question from the book, and we're going to determine whether or not Sean's algorithm gives you a really good approximation of that limit. Okay. Before we begin, Michelle, question.
Wait, Sean, does your code account for like fractions and stuff, like if you put like 1/4, or do you have to put like 0.25 instead, or what?
I never thought about that.
My guess is you're going to have to convert the fraction to some decimal.
I would prefer decimal.
Something tells me, Michelle, because we're dealing with doubles and all that.
You can't use fraction.
Yeah, if the limit involves a rational function, we may have to introduce coefficients that are decimal.
Yeah.
Okay?
Okay.
Okay, Victor, do you have a question? Do you have a problem from your calculus book just to test Sean's algorithm?
Yeah.
Okay, so what is the limit?
Just tell me the
Yeah, just tell us the limit.
Okay, the limit's 19.
No, the fun. I
No,
need a
what
function
is it?
first.
What is the question?
Oh, there you go.
The limit of 4x squared plus 3
Okay.
as x approaches, what is it?
4
As x approaches to
x squared
plus 3,
plus 3,
as x approaches 2.
and then as x approaches 2. Okay, so 1, as x approaches 2.
Yeah. Look at that, 19.
Wow.
Very good.
Got another
Very
one?
impressive,
Got
Sean.
another one?
I think Sean has proven himself. No need to do an endless number of functions here. Okay, very good, Sean. Very good. Alt P.
Oh,